This is a hands-on class, so open the lab guide and build alongside me. So far in this course, everything Claude has done has come out as text and 82112, answers, summaries, structured data. And that is powerful, but it has a hard limit. On its own, a language model cannot look up today and as weather. It cannot reliably do exact arithmetic on large numbers. It cannot check your database, send an email, or take any action in the real world. It can only produce words. Today, we shatter that limit with one of the most important capabilities in all of building on Claude: tool use. Tool use lets Claude call functions that you provide an 8212, your code an 8212, to fetch live information, perform precise calculations, query systems, and act in the world. You give Claude a set of tools, and when answering a request would benefit from one, Claude asks to use it. Your code runs the function and hands back the result, and Claude weaves that result into its answer. This single mechanism is the leap from a chatbot that talks to an agent that does. It is how AI assistants check real data, complete real tasks, and take real actions. Today, you will learn what a tool is, how to define one, the request-run-return loop at the heart of tool use, how Claude chooses among tools, and how chaining the loop builds an agent. Let us give Claude some hands. Here is what we will build today. First, why tools matter. Second, what a tool is. Third, defining a tool. Fourth, the tool used loop. Fifth, how Claude chooses a tool. And sixth, building an agent. Let us begin. Let us start with the limitation tools remove, because it defines everything Claude can and cannot do without them. By itself, a language model does exactly one thing. It produces text. It predicts and generates words, brilliantly and 8212. But that is the entirety of its native ability. It has no direct connection to the outside world. It cannot see live data because its knowledge is frozen at training time. It cannot reliably compute a large multiplication because it is pattern matching language, not running a calculator, and it certainly cannot do anything, any2 pastor, not send a message, not update a record, not book a ticket. It can only talk about these things, not do them. Tools change that completely. A tool is a way to connect Claude to your code and 8212 to functions that can do the things Claude cannot. Give Claude a weather tool and it can fetch today a 939's actual forecast. Give it a calculator tool and it can compute exact results. Give it tools that query your database or call an external service, and it can look up real current information and even take actions. Tools are, in effect, hands for a mind that otherwise only has a voice. They let Claude reach out of the text box and interact with real systems and real data. And this is precisely the transformation from a chatbot into an agent. A chatbot answers from what it already knows. An agent can gather information it does not have, use precise capabilities it lacks natively, and take steps toward completing a task in 84 because it can call tools. Now, same Claude, given the right tools, stops being merely a conversationalist and becomes something that can actually get things done in the world, check the live status, run the calculation, fetch the record, perform the action. Nearly every impressive AI application you have seen, NI212, the ones that do real work rather than just chat, NI212, is built on this foundation of tool use. It is the capability that turns language understanding into useful action. So learning tools is learning how to make Claude genuinely capable. So the takeaway, on its own, a language model can only produce text and 812. It cannot fetch live data, do exact calculations, or act in the world, and 812, and tools remove that limit by connecting Claude to functions you write, giving it hands to reach beyond words. This is exactly what turns a chatbot that talks into an agent that gets things done. Let us define, simply and precisely, what a tool actually is, because the concept is far less mysterious than it sounds. A tool is just a function and 8212, a piece of code that you write, and 8212, that you make available for Claude to call. That is the whole idea. It is ordinary programming, a function that takes some inputs, does something, and returns a result. What makes it an 8280 tool and 8280 OI is simply that you have told Claude it exists and it is allowed to ask for it to be run. There is nothing magical inside. The magic is in Claude being able to decide to invoke your everyday functions at the right moment. These functions can be anything your code can do. A get weather function that takes a city and returns the current conditions. A calculate function that takes a mathematical expression and returns the exact answer. A search orders function that takes an order number and looks it up in your database. Each is a normal function you would write anyway. Each becomes a tool the moment you expose it to Claude. The range is limited only by what you can program and a tool. Fetch data, compute, call other services, trigger actions and a tool, because a tool is just your code and your code can do a great deal. So the right mental model is that each tool is a specific capability you are granting to Claude. By giving it the weather tool, you grant it the ability to know the weather. By giving it the orders tool, you grant it the ability to look up orders. You decide exactly which capabilities Claude has by deciding which tools you provide, and A212, and Claude in turn decides when each granted capability is worth using for a given request. This keeps you in control. Claude can only do what your tools allow, and you choose that set deliberately. A tool then is nothing more than a function of yours plus permission for Claude to call it an A200 tool. And that simple thing is what makes Claude able to act. So the takeaway, a tool is simply a function you write, an A212 get the weather, do a calculation, look up an order, an A212 that you expose for Claude to call. There is nothing magical inside, and each tool is a specific capability you deliberately grant. So Claude can only ever do what the tools you provide allow. To make a function available to Claude, you describe it in a tool definition. Getting this definition right is most of the skill of tool use, so let us look at its parts. A tool definition has three key pieces. First, a name ENC A20212, a short identifier for the tool, like ENC A202, get underscore weather, ENC A20202. Second, a description ENC A20202, a clear plain language explanation of what the tool does, and crucially, when it should be used. And third, the inputs and A252, a specification of what parameters the tool takes and their types, such as an A252, a city, which is text, and A25252. Together, these tell Claude everything it needs to know to use the tool, what it is for, and what information to provide when calling it. Of these three, the description is the most important, and it is where beginners most often go wrong. Claude does not see inside your function. It decides whether and when to use a tool entirely from your description of it. So the description must clearly convey the tool and the tiny 9's purpose and the situations it applies to. A22 Pony gets the current weather for a given city in A22 Pony, tells Claude exactly when this tool is relevant, and A22 Pony, a question about weather, and A22 Pony, and when it is not. A vague or misleading description leads Claude to use the tool at the wrong times or misusing it when it should. You are, in effect, writing instructions to Claude about your tool, and clarity here directly determines correct behavior. The practical guidance follows directly. Write your tool definitions with care, as if explaining the tool to a smart new colleague who will decide when to reach for it. Give it a clear name, a description that precisely states what it does and when to use it, and a well-specified set of inputs. When all three are clear, Claude uses the tool correctly and reliably, and 8-1-12, calling it in the right situations with the right inputs. When the description is fuzzy, tool use becomes unreliable. So the definition is not boilerplate. It is the interface through which you communicate a capability to Claude, and time spent making it clear pays off in every interaction. And today in IN 319 S-Lab, you will write these definitions and see how the description shapes Claude and T9's behavior. Notice, eine, parken, and each color. You make a function available with a tool definition, and each color 202 tha, a name, a clear description of what it does and when to use it, and its inputs and A2 file, and the description matters most because Claude decides whether and when to call a tool entirely from it. Write it clearly, like instructions to a colleague, and Claude will use the tool correctly. Now the heart of it, what actually happens step by step when Claude uses a tool. This is a loop between Claude and your code, and understanding it makes everything concrete. It begins when Claude decides a tool is needed. Instead of replying with a normal text answer, Claude responds with a request to use a tool. It says, in effect, NA200 please run the get weather tool with the input city equals Pune. NA200 this is not the final answer. NA200 it is Claude pausing to ask for something it needs, naming the tool and providing the inputs. Your application receives this request rather than a finished reply. Then it is your Claude 39 Sather. Your application takes Claude 39 Sather actually runs the corresponding function and 8200 all. It calls your Rui get weather code with the city Pune, which goes off and fetches the actual current weather. This is the step where the real work happens. In your code, outside of Claude, the database is queried, the calculation is performed, the external service is called. Claude asks, your program does. Finally, you send the result back to Claude. Your code takes the function nd39 s output and 8084 280 ceni 31 degrees and sunny 8080 8084 and returns it to Claude as the result of the tool call. Now Claude has the information it was missing, and it uses that result to compose its actual answer to the user. NA2i 200 2i 8 NE 200 200 degrees and sunny in Pune 8 200 200 200 200. So the full loop is Claude requests a tool, your code runs it, you return the result, and Claude answers using it. Claude never runs your code itself, and A2112 it asks, you execute, you report back. That clean separation is the entire mechanism of tool use. And every tool interaction, however sophisticated, is built from this one request run return cycle. Grasp this loop, and you understand how Claude acts in the world. So, the takeaway, tool use is a loop between Claude and your code, and A212 Claude responds not with an answer, but with a request to run a name tool with inputs. Your application actually executes that function and does the real work. And you return the result to Claude, which then uses it to answer. Claude asks, you run, you report back every time. In real applications, you rarely give Claude just one tool and 8080 fall. You give it several, and Claude decides which, if any, to use. This selection is a big part of what makes tool use feel intelligent. You can provide Claude with a whole set of tools at once, an 8212, a weather tool, a calculator, an orders lookup, and more, an 8212, each with its own clear description. Claude reads all of these descriptions and holds them in mind. So when a request comes in, Claude is not limited to one capability, it has a whole toolbox available, and it considers the full set in light of what the user actually asked for. This is what lets a single assistant handle many kinds of tasks. Then, for the given request, Claude chooses. If the user asks a maths question, Claude picks the calculator tool. If they ask about an order, it picks the orders tool. It matches the request to the tool whose description fits, based on the purpose you wrote for each. This is exactly why clear descriptions matter so much. They are what Claude uses to route each request to the right capability. Given good descriptions, Claude reliably reaches for the appropriate tool for each situation, the way a knowledgeable person picks the right instrument for a job. And crucially, Claude can also decide that no tool is needed. If the user simply says hello or asks something, Claude can answer directly from its own knowledge. It will not force a tool call, an A212. It will just reply normally. Claude uses tools when they help and skips them when they do not, judging each request on its merits. This is what makes a tool-equipped Claude feel natural rather than mechanical. It does not blindly run tools, it decides, per request, whether a tool is warranted and which one, and only then calls it. So by offering a well-described toolbox, you give Claude the flexibility to handle a wide range of requests, choosing the right capability each time or none at all. that judgment over many tools is much of what distinguishes a capable agent from a simple script. So the takeaway, you can offer many tools at once, each clearly described. And Claude reads them all and chooses the right one for each request and 82 poll, matching the ask to the tool whose purpose fits an 82 poll. Or decides no tool is needed and simply answers. This per request judgment, powered by good descriptions, is much of what makes a tool-equipped Claude feel genuinely capable. Everything comes together when we chain the tool-use loop, because that is precisely how you build an agent that can complete multi-step tasks. Let us see how a single loop becomes real capability. A single pass through the loop and A212. Claude requests a tool. You run it, you return the result, and A200 handles one step. But Claude does not have to stop there. After receiving a tool and 29's result, Claude can look at it and decide it needs another tool to continue and 82 pal, and request that one too. Your code runs it, returns the result, and Claude may request yet another. The loop repeats, tool, result, each step building on the last, with Claude directing the sequence based on what it learns at each stage. This chaining is what lets Claude accomplish tasks that take several steps and several capabilities. Imagine a request like an 8000 or 20, find my most recent order and tell me if it will arrive before the weekend. 8000 or 20, Claude might first call the orders tool to find the recent order, then, seeing its shipping details, call a delivery estimate tool. Then perhaps a calendar tool to check the date and 8 hola to, and only after gathering all of that produce a final answer. No single tool could do it. The task required orchestrating several, each informing the next. Claude drives that orchestration, deciding at each step which tool to call given everything it has learned so far. And that is exactly what an agent is, a system where Claude loops through tool calls, reasoning about the results and choosing the next action, until the task is complete and it can give a final answer. The pattern is a loop, an E200 hull. Think, act with a tool, observe the result, think again, an E200 hull, running until the goal is reached. Your code provides the tools and runs this loop. Claude provides the reasoning that decides what to do at each turn. From the simple structure an A212 valve, the tool use loop, repeated and directed by Claude and A212 valve, emerge the capable AI agents that can research, plan, and complete genuine multi-step work. So building an agent is not a separate exotic skill. It is tool use, looped. Master the single loop, chain it, and you can build assistants that do real, complex tasks. In 3939 Slab, you will run a multi-step tool interaction and watch Claude orchestrate it. So the takeaway, chaining the tool use loop builds an agent and A212. After each tool result, Claude can decide to call another tool and another, orchestrating several capabilities across multiple steps until the task is done, and it gives a final answer. An agent is simply Claude looping through think, act, observe with your tools. So mastering the single loop and chaining, it lets you build assistants that do real, multi-step work. Before we recap, a crucial note, because tools give Claude real power, and power calls for care. Using tools well means using them safely. First, remember that Claude decides which tools to use based entirely on their descriptions. So clear, accurate descriptions are not just about correctness and 812 hove, they are about control. A vague description can lead Claude to use a tool in situations you did not intend. Precise descriptions keep Claude and 39's tool use predictable and aligned with what each tool is genuinely for, which is your first line of safe behavior. Say clearly what a tool does and when it should and should not be used. Second, guard your tools in code, because Claude N99's request is not a command you should blindly obey. Validate the inputs Claude provides before acting on them, exactly as you would validate any input to a function and 80-1 tool. Claude can make mistakes, and a bad input should be rejected, not executed. And for any tool that takes a real action or changes data, and 8200 sends a message, updates a record, spends money, and 8200 add real safeguards, permission checks, limits, or a human confirmation step for the consequential ones. A read-only weather lookup is low risk. A tool that deletes records deserves serious protection. Treat a tool call as a request to be checked, not an order to be followed. And third, handle tool errors gracefully by returning them to Claude. When a tool fails, an A212 the service is down, the input was invalid, no order was found, and A212 do not crash. Return the error as the tool result. Claude can then read the error and adapt, try a different approach, ask the user for clarification, or explain the problem. This makes your agent robust rather than brittle, able to recover from the inevitable failures of real systems. Clear descriptions for control, validated and guarded tools for safety, and graceful error handling for robustness, and 8200. Those three habits let you grant Claude powerful capabilities without losing control of what it can do. Tools are power. Wield them deliberately. So the takeaway, use tools safely with 3 habits and 82 well, write clear, accurate descriptions since they control when Claude uses a tool, validate inputs, and add real safeguards to any tool that acts or changes data rather than blindly executing Claude NPS requests. And return tool errors to Claude so it can adapt and 81200 R12, granting powerful capabilities while keeping control. Let us consolidate into the habits that make tool use reliable and safe in practice. First and foremost, write clear tool descriptions. This is the highest leverage thing you do because Claude and Shine's entire decision of whether and when to call a tool comes from its description. State plainly what the tool does, when it should be used, and when it should not. A well-described tool is used correctly and predictably. A poorly described one causes wrong or missing calls. Treat each description as the instruction manual you are handing Claude for that capability and invest in making it precise. Second, validate and guard. Never treat Claude and IRTTITS tool request as an unquestioned command and 8 IR 2 IR 200 and I 200 IR 200 IR. Check its inputs before running and protect any tool that takes a real action or modifies data with appropriate limits, permissions, or confirmations. Give read-only tools a light touch and consequential, world-changing tools serious safeguards. This keeps powerful, tool-wielding code firmly within the bounds you intend, so capability never becomes risk. And third, handle errors and think in loops. Return tool failures back to Claude as results, so it can adapt rather than crash. And remember that real capability comes from chaining the loop and 8202. So design your tools to compose, each doing one clear job, so Claude can orchestrate several into a multi-step solution. Clear descriptions, careful guarding, and robust looping and 8112. Those habits turn tool use from a neat trick into the reliable foundation of genuinely capable, safe AI agents. Get them right, and you can confidently give Claude the hands it needs to do real work in your systems. So the takeaway, make tool use reliable and safe with 3 habits and 8202 HOV. Write clear descriptions since Claude decides entirely from them, validate inputs, and guard any tool that acts or changes data rather than obeying blindly. And handle errors by returning them while designing composable tools Claude can chain and 8212, turning tool use into the dependable foundation of capable, safe agents. Let us gather the whole class in one breath. On its own, Claude only makes text. Tools let it fetch data, compute, and act N80 turning a chatbot into an agent. A tool is simply a function you write and make available for Claude to call. You define it with a name, a clear description of what it does and when to use it, and its inputs. The loop is, Claude requests a tool, your code runs it, you return the result, and Claude answers using it. Given many tools, Claude chooses the right one from the descriptions and A212 or decides none is needed. And chaining that loop tool after tool is how Claude completes multi-step tasks as an agent. Next, class and 80-12 RAG, giving Claude your own knowledge to draw on, one idea at a time. That is tool use and